guys, so we are going to start with 6.5, which is a continuance of the trig function graphing, okay? So 6.5, graphs of the tangent, cotangent, cosecant, and secant functions. So we're going to start with the parent function of tangent. So what I normally do is I normally make a coordinate plane here. Here's my input and my output. Okay. So here's what x and y equals to, oops, this pencil's broken. Y equals to tangent of x. So by now you have, if I put in 0, okay, so this is 1 comma 0. Tangent is y divided by x, so that's going to be 0 divided by 1. It's going to be 0. So at 0 radian, y, or the output, is 0. So the next one I'm going to use is pi over 4. At pi over 4, as you remember, we're going to have tangent of pi over 4 is going to be 1, okay, from your unit circle. Then this dot is going to be 0 comma 1. So what's happening at pi over 2? So at pi over 2, y divided by x, 1 divided by 0, which is really undefined because you can't have 0 in the denominator. So that's going to be undefined. Then this dot over here, tangent at 3 pi over 4, is going to be a negative 1 according to your unit circle. Then this angle right here is negative 1 comma 0. Y is 0 divided by negative 1. So negative, I'm sorry, not negative. At positive pi, I'm going to use 0. Then this is 5 pi over 4. At 5 pi over 4, your output, tangent of 5 pi over 4, is positive 1. This is 3 pi over 2. That means the order pair is 0, negative 1. Y is negative 1, x is 0, so negative 1 divided by 0 is undefined at 3 pi over 2. So that's undefined. And 7 pi over 4, which is this over here. 7 pi over 4, tangent at 7 pi over 4 is going to be negative 1. And back at 2 pi, which is the same as 0, we're going to have tangent of that is 0. So here is the entire unit circle of inputs and then the output for tangent. So that looks like my highest output is 1. My lowest output is negative 1, so the two take marks. Looks like I'm going from 0 all the way to 2 pi. Here we go, 2 pi. Let's do a negative as well, right? Might as well. Well, let's do, okay. So what if, here's a pi. Here's pi over 2. And then I have a half, which is a quarter. So half of pi over 2 is a quarter, which is pi over 4. Okay. So that means this is 1 pi over 4. This is 2 pi over 4. This is 3 pi over 4. 4 pi over 4 reduces to a pi. Okay. This is 3 pi over 2 right here. This is 5 pi over 4. Okay. 1 pi over 4, 2 pi over 4, 3 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. And why do I have an extra one? Let's count that again. Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4 reduces to a pi. 5 pi over 4, 6 pi over 4 reduces to 3 pi over 4. 7 pi over 4, I'm sorry, 8 pi over 4 reduces to 2 pi. Okay, so that works. So let's see what's happening. What does it look like? So 0 is 0, so that's my first dot. Let's just use a different colored pen here, because that way, okay. Pi over 4, I'm going to go up to positive 1. Pi over 2, it's undefined. It's undefined, so obviously we're going to use an asymptote. Then 3 pi over 4, we're going to go to negative 1. At pi is 0. 5 pi over 4, we're going to get positive 1. 3 pi over 2, we're going to get another asymptote because it says it's undefined at 3 pi over 2. 7 pi over 4, we have a negative 1. So here's 7 pi over 4, negative 1. And 2 pi, we're getting 0. Okay. Look at this. This has 3 dots. This has 2 dots. So we know the pattern needs to continue somehow. So I'm going to go over here and make this into a negative pi. This is a negative pi over 2. half of that is going to be a pi over 4 negative. Okay, similarly, this is negative 3 pi over 4. Oops, I'm sorry, negative 3 pi over 2. Okay, and then half of that and half of that to make it into a quarter unit. So if I were to continue the dots, would you agree that I would, okay, so check this out, I would have another dot over here at negative 1. And then I would have the next one over, looks like there's an asymptote. So I'm going to have an asymptote of a negative pi over 2 here. So that's sort of the trend. Or if I want to go one tick mark over, another quarter pi over 4 over, I would have another dot above. And if I want to make another tick mark, another pi over 4 over, I would have another asymptote if I want to follow the pattern. Now this is not a line, but as you know, anytime you have an asymptote, according to definition of asymptote, it approaches, right? So it looks like a lazy S. Okay, like x to the third, okay, function. So we're gonna keep on going forever and ever and ever. Okay. So technically, I can plot the dots again. I'm going to start from the top, which is positive 1, go to 0, go down to negative 1, and then asymptote. Okay, so if I want to keep on going forever, this is what I would have. All right, so let's talk about the amplitude and period of tangent. Okay, so amplitude. Is there a height that we can quantify? Okay, is it a maximum height from the center? There's no amplitude for tangent because it goes up forever and it goes down forever. So the amplitude for tangent, there's no such thing. But the period, how far did it go before it repeats? Looks like it repeats every time we have an asymptote, right? So the distance of repeating. So let's take from here to here. See that right there? From that first asymptote to this asymptote. It looks like the first asymptote is pi over 2, and the next asymptote is 3 pi over 2. So if I subtract 3 pi over 2, 3 pi over 2, subtract a pi over 2, would you agree that 3 pi minus a pi is 2 pi divided by 2? So the period of tangent is pi, okay? So the formula is going to be pi divided by absolute value of b. Remember, cosine and sine, we had 2 pi divided by absolute value of b. But for tangent, if you look at this, it only repeats every pi distance long, okay? Every pi distance long. So the period for tangent is not, I want to tell you, is not the same as cosine and sine. So let's talk about the domain. The domain of tangent, okay, it keeps going on forever, except every time we have these silly asymptotes. So we have to exclude those. But how do we exclude all of it? We can't really sit here and list all of it. So what we need to do is x, the domain, is going to be all reals, excluding, okay, pi over 2. We're going to exclude 3 pi over 2. That's for sure. The next one is 1 pi over 4, 2 pi over 4, 3, 4, 5, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4, 10 pi over 4. This is 10 pi over 4, reduce that down. 10 pi over 4, reduce that down to, ooh, you can't really see that. What's 10 over 4 reduced? 10 pi over 4. Reduce that 5 pi over 2. Okay, so 5 pi over 2. And then over here we have a negative pi over 2, negative 3 pi over 2 on the left, right? These are all the x's that we need to exclude, dot, dot, dot on both ends. So is there a formula that we can come up with? Because there's no way I would be able to sit here and list this out forever. But looks like we're adding, okay, from pi over 2 to 3 pi over 2. Looks like I'm adding a 2 pi over 2, which is reduced under pi. Similarly to this one, I'm adding 2 pi over 2 to get a 5 pi. If I, from negative pi over 2, add 2 pi over 2, I would get to positive pi over 2. So if we are going to sit here and list this out, would you agree that domain is going to be all reals, excluding? I want to start with the first non-positive here. I'm sorry, first small positive number here. Pi over 2 plus 2 pi over 2, which is reduced onto a pi, k. Okay, we're going to exclude every time this happens. And we have to define k, where k is, looks like what happened when k is 0. Then I would have a pi over 2. When k is 1, then I would have a 3 pi over 2. So it looks like k is any integer. Okay, so that's what's happening to the domain. You cannot sit here and list out all of the exclusions because there are unlimited. So you have to write an equation for it. The range, it goes up forever, it goes down forever. So your range is from negative infinity to infinity. Symmetrical. Is it symmetrical about the y-axis? So if I take this and flip it over, is there something on this side? Nope. Is it symmetrical about the origin, which is odd? Is there something from quad 1 that I can get in quad 3? And so that is the case. So we know that it's an odd symmetry. Okay, odd symmetry, if you remember, f of negative x equals negative f of x. Okay, or you can even write f of x equals negative f of negative x. It's like flipping it over the x-axis and flipping it over the y-axis again to get an odd function. Oops, you can't see that. Okay. Period. Okay, we talked about the period. So the period is going to be pi divided by absolute value of b, which in the parent function, tangent of x, is just simply pi for parent function. Okay. X-intercepts. Now this is going to be interesting. Let's see where all the x-intercepts are. One's at 0, one is at pi, one's at 2 pi. So if I would have to guess the x-intercepts, they are at pretty much, I would have to add a pi k every time, right? So pi k, where k is any integer, any int, okay? Because if I start at 0, when k is 0, I would have 1 at 0. When k is 1, I would have an x-intercept at pi. When k is 2, I would have an x-intercept at 2. Y-intercept, you only have one location, which is 0, 0. Maximum and minimum, because it goes up forever and goes down forever, there's none. Okay? You can write NA or you can write none. So that is the parent function. Alright, so now, because cotangent is the reciprocal of tangent, okay, now I just want to remind you guys, the reciprocal function is not the same as the inverse, okay? So when you say the reciprocal, you are actually dividing it by 1. When you're taking the inverse, you are actually switching the x and y value, which are two different things. Okay, so since this is the reciprocal of the tangent function, your amplitude and the period will also be the same as the tangent function. So amplitude would be none. Period, you would have the same formula. I'm sorry, it's not. You're going to have a pi divided by absolute value of b. And since this right here, your b value, which is, this is 1x, so your b value is 1. So the period for cotangent, the parent function, is pi. Okay, this is the formula for the period. So, and remember, since, look at cotangent. Since the period is 1, I can technically just have these inputs, and I don't need to go further on the bottom because it's going to repeat itself. So let's see how many inputs I need. 1, 2, 3, 4, and 5 inputs. And that is exactly the same amount of inputs, the same number of inputs we had for sine and cosine. We always have 5 inputs for sine and cosine. Now we're also going to have 5 inputs for tangent and cotangent. And that's all I'm going to use, just the 5 inputs. Okay, so let's make our table. X, Y, 0, and we're using pi over 4 because tangent and cotangent at pi over 4 is just simply 1. Pi over 2, 3 pi over 4, and we're now back 1, 2, 3, 4, and then back at pi. Okay, so let's talk about where these things are. Okay, so cotangent, this is going to be 1, 0. So one input is 0 degree or 0 radian. Cotangent is the reciprocal of tangent, so it's x divided by 0. 1 divided by 0 is undefined because you can't have 0 in the denominator. At pi over 4, cotangent pi over 4 is the same as tangent pi over 4. It is 1. At pi over 2, this is 0, comma 1. So when you take x divided by y, 0 divided by 1 is 0. At 3 pi over 4, you're going to get a negative 1 according to your unit circle. And back at pi, this is negative 1, comma 0. When x is negative 1, divided by y, which is 0, does not exist. Okay, it's undefined. So since I have a period of pi, I'm going to go over here and write pi. I'm just going to graph out 3 different cycles. Okay, 2 positive and 1 negative. And every period, just like sine and cosine, I'm going to go in and make 4 equal intervals. Okay. If this is pi, right in the middle is pi over 2. If this is pi over 2, right in the middle is going to be pi over 4. You only need to label a couple of these take marks, so I know that each take mark is worth a pi over 4. My output looks like the high is, I need to mark it at 1, and the low is negative 1. And let's see where this goes. When x is 0 radian, I have an asymptote because it says it's undefined. Okay. When x is pi over 4, I have a positive 1. When x is pi over 2, I have a 0. When x is positive 3 pi over 4, I need to go down negative 1. And when x is pi, I have an asymptote. Okay, look at that. I have 3 dots, okay, which is sort of similar to this, right? But the dots, look at the dots. It's kind of decreasing here, and this is increasing. So cotangent is very similar to tangent, except the asymptotes are moved over a little bit, and it's a decreasing function. And that's what happened. Okay. And then I'm just going to repeat the pattern. If there's an asymptote at pi, there has to be an asymptote at 2 pi, and there has to be an asymptote at negative pi. Okay. And I have 3 dots. The middle dot is right in the middle of my 4 equal intervals. And the dot on the top, it's over here on the left. The dot on the right, it's on the bottom. And that's how I'm going to graph this out over a couple of different periods. Okay. Here's the middle, and then 0. Top left, bottom right, and repeat. So I just finished 3 cycles, or 3 periods. So now let's just answer all of these awesome things right here in the box. Okay, domain. The domain is we're going to have to exclude all of the asymptotes. So it looks like I'm excluding 0, a pi, a 2 pi. That is very similar to the x-intercept, right? Look at the x-intercept, 0, pi, 2 pi. So technically I'm going to use the x-intercept from tangent and write it in my domain. So domain is going to be all reals, excluding the same equation as the x-intercept on the tangent, where k is any integer. The range, very similar to the tangent, is going to be negative infinity to infinity. Okay. Okay, now symmetry. Symmetric about what? If I were to fold it, is it going to give me, if I were to fold it along the y-axis, is it symmetrical about the y? Now, if it's symmetrical about the y on the left-hand side, I would have this curve, but it's not the case. So now, is it symmetrical about the origin? It doesn't look like it, right? I mean, think about it. I can't really see it. So that's why I'm going to pick a few points. Okay. Odd symmetry. We have that equation. We have f of negative x equals negative f of x. So when I pick a positive x, for example, pi over 4. So f of pi over 4. Okay, when I do this, it should be identical to f of a negative pi over 4. That's what I'm trying to compare. So pi over 4, cotangent of pi over 4, which is right here, is positive 1. Positive 1 times negative 1 is negative 1. Whoa, okay. Well, f of negative pi over 4, well, I don't have it on my chart, but I'm just going to go over. Each take mark is worth a pi over 4, so if I want a negative pi over 4, I would just go here. Here's cotangent of a negative pi over 4. the output is negative 1. Negative 1 is the same as negative 1. Check. Oh, that's just a coincidence, right? It can't be the same. How about if I go and pick 3 pi over 4? So f of a negative 3 pi over 4 should be identical to negative f of a positive 3 pi over 4. Is that true? Okay, let's check it out. I have 3 pi over 4 on my table, so its cotangent of a positive 3 pi over 4 is a negative 1. But negative 1 times a negative in front is going to be positive 1. So now I'm just going to go over to the negative side of 3 over 4. 1 pi over 4, negative 2 pi over 4, negative 3 pi over 4. At negative 3 pi over 4, the output is also positive 1. Check. Whoa. So even though this doesn't look like a symmetry about the origin, it actually is. Okay, so symmetry, odd, or about the origin. Period, we talk about the period. The period for cotangent is pi. X-intercepts. X-intercept looks like is at pi over 2, 1 pi over 2, 2 pi over 3, 3 pi over 2, and a negative pi over 2. So if you look at this, don't we already have something that's dealing with pi over 2, 3 pi over 2, and negative pi over 2? It looks like it was the domain, right? So we can just use the domain equation to list out all the x-intercepts. So x-intercepts, all the x-intercepts are at, let's move it down a little bit. It's very similar to, well, exactly the same as the domain, except we don't say exclude. We actually want this equation. So x-intercept is at pi over 2 plus pi k. And keep in mind, this is not the only equation that you can write. You can write other different equations as long as when I grade them and I test them out, it's still the same, where k is any integer. Okay, so let's talk about the y-intercept. The y-intercept, is it ever going to touch the y-axis? No, because there's an asymptote here. So none. There's no max either, and there's no min. Okay. So we have no maximum and no minimum. Therefore, so what's the difference between cotangent and tangent? Okay. Cotangent and tangent. Cotangent is an increasing function. Tangent is a decreasing function. The domain of cotangent is the same equation for the x-intercepts. Okay. The x-intercept on the cotangent is the same equation as the domain, right? Minimum and maximum, they're both none. They both have an odd symmetry, right? They both have the same period. So there's a lot of common things because these two are reciprocal of each other. All right, this is the end of the video, and I will talk to you guys. Or actually, I don't talk to you. I talk to myself. I will see you guys next time.